Okay, so now we're going to prove the alternate exterior angles theorem. Okay, and this theorem states if two lines cut by a transversal are parallel, then the alternate exterior angles are congruent. So based off of this diagram here, I'm saying if P, line P is parallel to line Q, then angle 1 is congruent to angle 7, and 4 is congruent to 8, because those are the alternate exterior angles, right? Okay, so I'm going to start off the proof with the corresponding angles postulate. Since I know that these lines are parallel, so by cap, I know that P is parallel to Q implies, or if and only if, right? Angle 1 is congruent to angle 6. Angle 2 is congruent to angle 8. Angle, let's see, 4, or I guess 3 is congruent to angle 7. And angle 4 is congruent to angle 5, right? All right, so by cap we have those. And then I'm going to use the vertical angle theorem by vertical angle theorem, right? I know that 1's congruent to 2. I mean, 1's congruent to 3, sorry. 2 is congruent to 4. 5 is congruent to 8. And 6 is congruent to 7. Okay? So all those vertical angles, I'm going to combine all of the ones I need together, right? So I know that angle 1 is congruent to angle 6, and angle 6 is congruent to angle 7, and angle 7 is congruent to angle 3. And I also know, so all of these are congruent together, and I know these pieces are congruent together. Let's see, 2 is congruent to angle 8. Let's see, and 8's congruent to 5. And 5 is congruent to 4. So look what I wanted. I wanted 1 is congruent to 7, which is what I have here. And I have 4 is congruent to 8, which I wanted here. So this implies that, let me see, 1 is congruent to 7. And, let's make sure, 4 is congruent to 8. And that is it. Very similar to the proof of the that we did for the alternate interior angle theorem.